Hey, welcome back to Physical Science. Now, last time we talked, we went over ionic bonds because there are three different kinds of chemical bonds we're going to go over. There's ionic bonds between metals and nonmetals. Today we're going to go over covalent bonds. Now, covalent bonds go on between two nonmetals. So remember that small group in the upper right-hand corner of the periodic table. All your nonmetals that like to gain electrons. They are going to be forming covalent bonds for us. So let's get on and get going. Make sure you got your notes out. Pause the video anytime you need to in order to get caught up on your notes. Alright, to start off with, let's take one of the nonmetals, fluorine. We're going to do the proton, neutron, electron thing here real quick because I want to show you the concept. You have to understand how a covalent bond works and why it works. Okay, so you got a fluorine atom here. It's got 9 protons, 10 neutrons, and 9 electrons. So we're going to take a Bohr's model down there. We're going to put the electrons in there. And if you count them, of course, we got 2 on the first ring. We got 1, 2, 3, 4, 5, 6, 7 electrons on the next outer ring. That gives us a total of 9. Okay. Now, remember from the last one, in order to make an atom chemically stable, or happy as we would like to say, that has to have 8, or has to have a full outer ring. And for the second ring, that means 8 electrons. So that fluorine has to have 8 electrons on the outside. It only has 7. So there's one vacancy, one more electron it needs right there in that circle, that ring you see there. I got the unhappy face to show you that fluorine is a frowny face and it needs to have one more electron. But we are not going to combine fluorine with some metal. There's no electron to transfer in. Now in this container of fluorine, of course, there's more than one atom. So we're going to draw another fluorine atom with a Bohr's model, and I want to show you what's going to happen. Both model atoms are unhappy. They both have only 7 electrons in the outside shell. But for the time being, so that they can be stable, what they're going to do is slide over and share the outside electron shell. And now if you look at the atom on the left hand side, there's 2, 4, 6, 8 electrons on the outside shell, and the one on the right is the same way. So even though they both only had 7, together if they overlap and share, that's the key word, make sure you got that one in your notes, it shares a pair of electrons, then all of a sudden we've got 8 on the outside. So let's turn those frowny faces to happy faces. We now have 2 chemically stable fluorine atoms as long as they're overlapping and sharing a pair of electrons. Okay, and that's how a covalent bond works. So now let's take a good look at the name. Yes, make sure you got the word sharing on there. Let's take a look at the word covalent. Co, the CO, if you're the co-owner of something, that means that you have to share ownership with somebody else. You're both equal partners in owning something, a car or a house, something. You're a co-owner with it. It means you have to share the ownership equally. So that's the beginning of the word covalent. And of course, if you look at the second part of the word there, bright orange, you got the CO on the front, and then it says valent. That comes from our word that we learned last time called valence. Remember the valence electrons? Those are the electrons in the outermost shell of an element. So what we're saying is that co means share, valent means they're sharing the outside electrons. So if you ever forget which is this bond, an ionic or is it covalent, all you got to remember is that covalent, the word, that means you're going to be sharing those outside electrons. Okay, let's go on to the next thing. And let's see, covalent bonds occur between 2 nonmetals. I already mentioned that. If you haven't written that down yet, make sure you get that on your paper. That's very important. That's one of those definitions you got to nail down. And to take this a step farther, we use 2 fluorine atoms there. Notice that they came together, and then so we put a little subscript 2 on there. So we're going to take 2 fluorine atoms that are going to chemically bond together. And you remember probably back from middle school when you're learning STEM words that di, the D-I-A, like on the word there, diatomic molecule. So that means 2 atoms that make up this molecule. So it's a diatomic. You actually know some other diatomic elements as well. Let's take a look at those. Oh, before I go to other ones, I forgot about this. I want to show you a Lewis dot structure instead of Bohr's models. Remember, the Lewis dot structure only has the valence electrons on the outside. You can see those two open spots, and we can make one slide over to the other one. Now they're both sharing outside electrons. Now, chemists have found a way to like shorthand this so they don't have to draw all the rest of the dots. To them, the only thing that's really important is those two dots exactly in between the two fluorine atoms, because those two are the two that are going to be shared. So what they like to do is sometimes just show those two dots, and then even then, instead of showing the two dots, they kind of want to show a bond, like a bridge. There's a bond in between those. So sometimes instead of showing two dots, they reduce it down to just showing a single line like that. It looks like F minus F, but that actually stands for that single line represents a pair, two shared electrons. Okay, so you would say that between two fluorine atoms, it shares one pair. There's a single line there, so it shares one pair of electrons. Now let's take a look at some oxygen. Looks like two eyeballs looking at you there. But those are two oxygen atoms. We're going to go ahead and put the Lewis dot structure on the outside. The valence number for oxygen is 6. So there's 6 electrons on each one of those oxygens. And you can kind of guess. You can kind of see that one pair, take the singles on each one, and each one of those are going to share and kind of pair up right there. I'm going to draw little arrows in there so you can see it. And then if you look to the right of those arrows, I show you that there's 2 oxygens, and there's those 2 big long lines again. Remember, each line represents 2 electrons being shared. So there's 2 lines, so that's what they call a double covalent bond right there. And since you've got 2 oxygens down there at the very bottom, I got a great big O2 down there. And you've seen that. If you've ever gone to a hospital or worked anywhere near the volunteer fire department, you'll see sometimes those big green tanks, and it says O2 on the outside. That's pure oxygen in them tanks. And again, that's 2 atoms, so that would also be a diatomic molecule. Now let's take a look at something besides 2 fluorines and 2 oxygen. Here we got a hydrogen, which is a nonmetal, and a fluorine. I think most of you can look at that because if you like playing around with Legos when you were younger, hey, this is perfect. You can see how that one hydrogen right there is just going to slide right over there and fit right in with that fluorine atom. Look at that. Forming that single bond. So you got HF right there. This one you know really well. You got hydrogens, each with 1 electron on the outside, 1 valence electron. There's our oxygen with 6 on the outside. You can see those 2 open vacancies in that oxygen. And those 2 hydrogens are going to slide right over there, and boink, there you go. You've got 2 hydrogens on either side of the oxygen. And so you know what that is, don't you? You got 2 hydrogens, 1 oxygen. Yeah, that's water. So water is actually a covalent bond. Okay, you got 2 hydrogens and 1 oxygen. This one here is kind of interesting. There's a lot of different parts. It's also kind of nasty. I'll explain that here in a second. But you see carbon's only got 4 electrons on the outside shell. Each hydrogen can come sliding in there and just perfectly fits it right in there. And CH4 is methane. And if you don't know what methane is, well, if you ever stood too close behind a cow or a horse or maybe your brother, good Lord, whew, sometimes they let it go, That's methane, my friends. That is methane coming out of the back end. So when you go and you eat food and you get a little gassy there, not to be gross, but what kind of gas comes out of you is methane. And yes, my friend, it is flammable. Do not test that theory. Please don't do that. All right, here's another one. This one you breathe out every day. You got 2 oxygens and carbons. You got double pairs. 2 double pairs of covalent bonds getting shared. It's getting kind of complex here. But that's how you breathe out carbon dioxide. Or if you like doing paintball shooting, or maybe you got a CO2 cartridge, pellet gun, or BB gun, maybe you use a CO2 cartridge, and that's exactly the chemical compound right there for that. Now, the other thing, remember all those single lines, I wanted to show you something. For those of you who are asthmatics, okay, I'm an asthmatic, and we have to have those emergency inhalers. And if you look inside the box, sometimes there's those instructions that are wrapped up, and if you ever unfold that thing all the way out and you look at it, chemists have drawn the actual molecule that creates the actual medicine that asthmatics need. Or if you got a really bad headache or you're really sore and you need to take some Advil or ibuprofen, there's the chemical structure for ibuprofen. And you remember all those single lines right there? Those are representative of all the little bonds that we just got done talking about. And notice those are all nonmetals in there. Okay?